Hello, in this module we will see how to work with case control study using R. Case control study, it is a prospective study where a group of patients followed for certain period of time, and in addition to that a group of control patients also observed for certain times, and treatment effect other exposure compared in cases with respect to control. One type of case control study can also be seen, or special or specific kind of design can also be seen in randomized control trial, where a group of patients being divided into two separated groups. One group given a experimental drug, another group given as placebo or existing drug, and during follow up studies their treatment effect compared, and we do find out the experimental or intervention group drug is having better effect in comparison to existing or placebo or not. So, there are so many challenges to handle the case control study data. Here we will see how to compare baseline measurement through box plot, and we will work on the R to handle the baseline measurements comparison. Here we will also work on with treatment effect comparison. In this study module, we will see how to generate statistical inference through linear modeling, and later we will see how to generate model selection procedure and get the best fitted model from the data set. In this module, we will see how to get box plot with R, the inference about box plot in R, treatment effect comparison, preparing the 2x2 table, linear modeling with covariance, and stepwise model selections procedure. It is to be mentioned that in case control study or in clinical trial data analysis, typically the same variable, that variable is primary endpoint of interest, may be used to reduce for any disease. That variable should be considered repeatedly over time, and during repeatedly over time this measurement of the variable and how these are changes over the time is considered, and based on that clinical trials interpretation is being carried out. In case control study as well as in randomized control trial, all patients baseline observations of primary endpoint of interest variable is considered. Here we are considering one case control trial where some patients were given therapy and some patients were given placebo, and the patients were for CHD, that is coronary heart disease patient, and those patients data on diastolic blood pressures has been measured repeatedly, and how these diastolic blood pressures changes over time through the therapy has been captured as a data, and we will see how to analyze these data and how to make statistical inference from this data analysis. So, here is the data set, and the first variable is assigned as a ID, and ID is assigned as 1 to 26. So, here 26 individuals information is considered, and second variable is DBP1, and as a DBP1 it is considered as the baseline diastolic blood pressures. It is to be mentioned that the diastolic blood pressure is considered when it is till 120 as a normal value. So, here these 26 patients diastolic blood pressure is considered as when it is considered as when it is captured as a baseline observation. So, before study initiation, before giving them any therapy. Now, third variable is this called as a DBP2. It's the first visit measurement of those same patients diastolic blood pressures. So for example, this, if we consider the first individual assigned as a 1, and his baseline observation of diastolic blood pressure was 110, and in the second visit his diastolic blood pressure reduced to 108. So this one kind of data. Again, treatment is given as a TRT. So if these 26 patients treated with any intervention or experimental drug, they were assigned as a 1 treated. Otherwise, if they treated as a placebo or without any drug, the drug is given as 0. So treatment having 2 endpoint, one is either 1 or 2, 0. So 0 represent they were not treated and 1 represent they were treated, and this whole data set is assigned as my data. Here we are not showing this other variable information like DBP2, DBP3, gender and age. So this data set can also be assigned like DBP2 is considered, and like age of this patient, of 26 patients, male or female, that is assigned as a gender here. So now for further analysis we are calling the attach of my data, and the next slide we are going for our first objective, that is box plot with her. So this function is called box plot, and into there we are using parentheses, we are putting DBP1 follows to TRT. So here only the DBP1 is considered and how the treatment effect on there. However, since we have considered the DBP1 here as a baseline, so maybe there should not be any treatment effect on there. There is not any ideally there is not any meaning to check the treatment effect on DBP1, but treatment effect from DBP2 onwards should be considered. But another intention can we consider that to check the treatment wise comparison on DBP1 is that is there any biasness of the selections of those patients were there or not. So patients were same in the both arm, that can be considered when you put DBP1 with treatment. So here as a left hand side we are putting DBP1 follows to treatment, that is TRT, and here we are putting the date, that is our my data, and again as the X lab we are putting treatment and Y lab we are putting DBP at baseline. So as a results, as output, we can see this snapshots taken from the R, and that is this box plot, and we can see both are having equal median value. This broad line, black broad line is showing this median value, and the both patients, both treatment groups of patients are having same, whereas those who are treated with placebo, this maximum and minimum value were quite high. Started from 100, maximum value was nearly 130 and minimum value was nearly 105. However, those are treated with intervention arm, their maximum and minimum value were between 120 to 107, like that. So that from this box plot we can make the graphical interpretation about the data. So here we can interpret that baseline DBP was, that is diastolic blood pressure, having no significant difference between these two treated arms. Now the same plot, same function can be used for DBP2 and DBP3 as well. And if we find that there is a box plot wise there is a difference, then we can interpret that which group is having better diastolic blood pressure reductions in terms of medium, that can be obtained. And here we are not showing these functions, but we can use later on the same function. So only we have to replace the DBP1 by DBP2 and again DBP2 by DBP3, and we can get the box plot comparison on that. Now we will go for another objective, that is called treatment effect comparison. It is to be noted that in any case control study, our intention is to find out that how treatment effect are behaving, how one treatment or acting treatment or experimental treatment is better than in comparison to placebo or its existing drug. So that can be obtained also by T-dot test, that is basically useful to compare the mean wise diastolic blood pressure comparison So here again we are putting as DBP1 with respect to treatment. So DBP1 follows by TRT is considered for my data, and that will use to compare the mean value between treatment, that is 1 and 0, and corresponding the diastolic blood pressure will be compared. Here the results are showing that Welch 2 sample t-test, and t value is coming 1.27 and degree of freedom is coming 18.79 with p value 0.2177. So whatever we are seeing that graphically by box plot that treatment were not having difference in terms of their selections, again this p value also showing that there is not any significant difference on their mean value, mean DBP value. As the p value, we are also getting that 95% confidence interval of this mean difference. So it shows that minus 2.09 to 8.59, and the mean in group 1 was 114.80 and mean in group 0 was 114.80 and mean in group 1 was 111.54. so these are not these mean are not significantly different. So here we are using these diastolic blood pressures baseline observations. However, that can be considered as selections of this individual, and the DBP1 can also be replaced by DBT2 or DBP3 or corresponding follow-up visit diastolic blood pressures. So again, it is requested to check the same functions and find out the how this measurement difference, treatment effect difference observed. Now we will go for another objective, that is we have mentioned as a preparation of 2x2 table. It is very simple, that is used as a function called table, and when we are putting as that table of TRT and gender, and we are putting that sex by TRT, assigning as sex by TRT, and we are calling sex by TRT, we are getting as a first row gender with TRT and treatment. So among these 26 individuals, 8 were female, those were treated with placebo, and 7 were male, those were treated with placebo. Again, 3 female were treated with treatment or existing or intervention treatment, and among these 8 male were given the treatment or intervention arm. So the one of the basic criteria or work is to preparing the table with respect to different parameters, variables in case control study. So again, these functions can be used, this table function can be used to make the 2x2 table among different variable. In earlier module, we have seen how to get the chi-square test or how to prepare the association between 2x2 table form. So here again we can use the chi-square dot test functions to get that is there any treatment wise or selection wise biasness was there among male or female or not, and that can be obtained by p value as well through application of chi-square dot t test that can be used. Now we will go to for second objective, that is results on 2x2 table. Here we are using this proportion dot test, that is another way to find out that proportions of male who are treated with intervention arm is different with female who are treated with intervention arm or not. So in place in addition to the chi-square dot test, we can go for prop dot test. Here as a result we are getting the 2 sample test for equality of proportions with continuity corrections factor. So here hypothesis is that proportions of male who are treated with intervention is equal with proportion of female who is treated with interventions arm. So now as a result we are getting the square value as a 0.8595 with 1 degree of freedom, having p value 0.3539, and alternatively it is a two-sided test considers, and of these point estimates the confidence interval also coming from minus 0.18 to plus 0.70, and the proportion for first sample is 0.53 and second sample proportion is 0.27. As a result, we are also getting a warning message that chi-square approximation may be incorrect due to this some cell is having less than 5 value. That again need to be considered in mind. So then again we can go for exact test. Now we are going for to find out the gender and age wise relation on diastolic blood pressure. So initially we had considered the treatment wise difference was there or not on diastolic blood pressures. Now we are considering combined effect of gender and age on diastolic blood pressure. So to get that we are using the function called LM. LM stands for linear modeling. So into the linear model we are within parenthesis we are putting diastolic blood DPP1 followed by gender plus age comma my data, and the whole function is assigned as a BM1. Now when we are calling that summary BM1, then we are getting that as a result LM formula of DPP1 followed by gender plus age with data equals to my data, and residuals measurements also given as a minimum to maximum value. Residuals predicted from this model is given from minus 10.77 to maximum 12.682, and coefficient, that is most important thing, as a estimate standard error and value of probability p value is coming, intercept coming 99.86 with standard error 4.97 and t value 20.08 and p value 4.41, that is highly significant. Now for prediction for gender for male is coming as minus 0.18 with standard error 2.56, t value minus 0.07 with probability p value with 0.94, and age is coming 0.32, standard error 0.11, t value 2.99, and p value is significant. So here it can say that age is having severe highly influence on diastolic blood pressure value, and those are having high age or more age they are having high DBP value, diastolic value. Again for gender, since with corresponding to male it's coming minus, so it can be stated that male are having lesser diastolic value in comparison to female. However, that is not obtained as a significant level, that obtained with since p value coming 0.94, and that is the interpretation about the results. Male effect on sex and gender age. Here in a title we had mentioned that main effect model on sex, but we had put the data set as a gender, so both can be, it's a synonymous thing. So now we will go for graphical presentations of this data set. Now as a graphical presentations, as a response variable or dependent variable we had considered diastolic blood pressure 1, and followed by age is considered, and again PCH is considered as dot character for gender to put the line on the gender wise segregations on this data, and the data set specifically assigned as my data is called here as my data comma, where X lab is assigned as age and Y lab as baseline DBP. Now the abline function is used to get the BMI coefficients of 1 and 3 into the data set, into the graph. Now see the plot. This is the relation between age with this baseline DBP. So as a Y we are putting the baseline DBP, and as a X axis we are putting the age, and these male and females separately is given what is the corresponding relations as we are mentioning these functions, and this coefficients graph also shows that since those are having higher age, these are having higher baseline DBP, and however it's those male are having lesser value of towards diastolic blood pressure in comparison to female. However, a strong tendency, a strong pattern has not been observed between male and female, so that can also be observed through the p value, that no significance difference among male and female were there towards diastolic blood pressures that observed in the baseline. So this is the graphical representations of these relations between. Now we will go for ANCOVA test. Now in ANCOVA we are using new variable that is assigned as a DIFF, and it's as a difference between DBP1 and DBP2. Now this whole thing can be called through the function again that is called LM, and into the LM function we are putting DBP followed by T or T, multiplication of age, multiplication of gender, and assigned as a my data, where whole set thing is assigned as MO. And when we are calling MO, and then we are getting these coefficients, regression coefficient estimate for TRT and age and gender M. So again we are getting that intercept is having 3.32, TRT regression coefficient value coming minus 1.32. so those were treated with placebo, that is treatment with 0, they are having higher diastolic blood pressure, and those are having higher, here those are having higher age group, they had reduced more diastolic blood pressures, that's why age is coming as a minus 0.01. so here it is to be noted that here we are not considering the diastolic blood pressures, here we are considering the difference of diastolic blood pressures. So and with treatment and age and gender, so interpretations should be considered here that the difference for placebo group were high, treatment group for older age also the difference was quite high in comparison to younger people, and gender also those are having female, they are having high reduction of diastolic blood pressure in comparison to male. Now we will go for another stepwise model selection procedure. So model can be selected by different way, like here we are going for AIC, that is stand for Akai information criteria, and that is stand as M1 equals to step of M0. When we are calling that M1 equals to step of M0, automatically we will get the AIC value of this model as 39.35, and for considering treatment, age and gender, the AIC value is coming for minus 0.41, and when we are considering nothing, it's coming as minus 39.35. so step functions as a step equals to, we are getting AIC equal to minus 41.29. so value of AIC value is having lower, the corresponding model is better fitted. So here we are considering treatment, age and gender, so different combination of these factors can be considered, like only treatment, only age, only gender, or only treatment and age, or age and gender, or treatment and gender can also be considered separately, and corresponding AIC value can be obtained. And among these all AIC values, the model is having minimal AIC, that can be considered as the best fitted model on the scenario. So after putting this AIC value, corresponding regression coefficients value we are also getting. For another objective, fit the reduced model. Now since we are initially we are considered gender, age and treatment, now we will consider only treatment and age, and again the dependent variable is considered as diff, that is difference between the diastolic blood pressures 1 and 2, and the function is used as ln and assigned as m2. Now when you are putting the ANOVA function with the parenthesis of m2, we are getting the estimates value for regression, estimates value for treatment, age and residual. For treatment we are getting again the p value is less than 0.05. so treatment wise really difference has been observed, but age wise not observation has not been mentioned. So here the ANOVA function is, used to make the group wise comparison, and groups between treatment and groups on age also been considered. So as a residual value, mean residual value we are getting as 0.18. Since it's the residual, there is not a meaning to get the p value and f value here, and the whole results can be obtained and statistical inference can be drawn here. Now again we are calling this summary of M2. Again we are getting the intercept estimates, standard error, t value and p value, treatment regressions and coefficients estimates value, and age regressions coefficient estimate value. Like earlier we have seen, the same kind of interpretations can be obtained. Now we have mentioned here the difference between DBP1 and DBP2. The same kind of difference variable can be obtained between DBP3 and DBP2 and corresponding DBP4 with DBP3, like that. I think these functions can be used in other case control study as well, and we can get the graphical expression of the data like box plot. We can get the model fitting criteria like here we have found, and we can also generate the 2 by 2 table we can also get the statistical inference in terms of p-value for preparing the 2 by 2 table. Here we have seen how to handle case control study data, how to generate box plot, how to generate treatment effect comparison, and after that statistical inference on treatment effect comparison. I have also illustrated how to work with linear modeling for treatment effect comparison as well as model selections criteria to get idea about the best fitted model.